Hello, I am Makai Harkins, and this is my ENME435 final project.
The goal of this project is to use a Raspberry Pi with a camera, a line laser, and a lot of Python to create our own LiDAR systems used to map a target of interest on campus. With each of these 3D point clouds and GPS data, Dr. Mitchell plans to create an ever-evolving 3D map of UMD campus. And I'm glad to be able to be a part of it. This is my LiDAR sensor setup. I use an Arduino Uno and a line laser, Raspberry Pi with a camera, all mounted on a tripod with a lot of zip ties and hot glue, as well as a portable battery duct taped to the bottom of the tripod that allows me to power the Arduino and the Raspberry Pi without wires leading between my setup and my laptop, which helped with convenience. The Arduino powers the laser, which shines the line laser onto the target, and the Raspberry Pi camera takes a photo of the target and is able to determine the distance from each point from the target to the setup, depending on how far away the laser on the target appears to the center of the image that the Raspberry Pi takes.
This diagram provided in Homework 6 illustrates how the Raspberry Pi is able to determine the distance from the target and the camera. Between the laser and the Raspberry Pi, we use a distance of 12 inches in the LiDAR setup. As the distance from the target and the camera increases, the laser appears closer to the center of the image. And after calibrating, we are able to determine through any image how far away the target is for every single spot of the laser on the image that it takes. Doing this from many angles for each side of the target can give us a full LiDAR scan in high quality 3D point cloud. This is an image of how I was calibrating my sensor. From as many set distances, I take many photos, and I'm able to run it through a script and adjust the radian offset value and the gain value until the curve provided fits my points. Each of the red dots is the data that I collected by doing the calibration. And after using a radian offset of negative 0.0017 and a gain of 0.00005 radians per pixel, I was able to get this blue curve that very closely matched all of the data that I collected. And after this, my LiDAR system was successfully calibrated. The target I chose was the Kermit statue outside of Stamp. This video briefly shows my process of collecting the data. For each of those angles, I've run this code on the Raspberry Pi to take a photo of the line laser on the target. I do that for 5 different sides of the target until I have enough data. As I'm walking up, I show how, while it looks good on my phone camera, that the lasers on the statues didn't pick up well. The bench picked up great, and we'll see soon in my point cloud that the bench was able to really show the laser well on the images, but the statues had some struggles. I chose this target because I thought it would be really interesting to see the different depths of the statue, and I like that it had a normal shape of the bench with a very specific and detailed shapes with the statues. I also like the Muppets, so I thought it would be pretty cool to do this. But I had a lot of challenges while collecting this data. For example, one of the challenges I had was, as I said, the statues didn't show the laser well. Another challenge I had was that bush I just showed didn't allow me to get the right half of the back of the statue, though I tried my best with the other back angle to get as much as I could. Weather ended up being an issue. The week that homework 8 was due, it had rained multiple days that week, and I had an exam that week, and I struggled to find time, but I was able to get it done. One final issue that I had ran into was when I had went here to do my scan, there was a line of people waiting to scan the same target, so I ended up talking to them, and I ended up coming back the next day to finish my data collection. But Other than that, it turned out good, and I'm happy with my results. I'm happy with the process, and I'm happy with the target I chose. After collecting all my data on campus, I transferred the images of each angle from each side from my Raspberry Pi through a flash drive to my computer. For each side, I placed all of the images of each angle into the test data Raymond folder, and then I ran Python data generation.py, and it gave me a text file, which is the coordinates of each point in the 3D point cloud. After combining each of these, all 5 of them in Cloud Compare, trimming, filtering, arranging, and then merging into one final point cloud, I got this. I think it turned out pretty well. You can clearly see the bench. And you can even see, while Kermit, you can see of some points that would be around where Kermit would be sitting on top of the bench, but you can really see the man sitting there on the bench as well. You can see his body stick out from the bench, his head at the top, those dark red spots, his legs even sitting at hanging off the end of the bench. You can see all those, and I think that my 3D point cloud turned out really well. Increase the size, maybe help see it better. I think that helps you see it pretty well. But overall, I think it turned out well. If the actual statues, uh, if the laser showed up better on them on my Raspberry Pi camera, then you would definitely be able to see Kermit better and more details on the man. But otherwise, I think that you can see definitely where they would are both be sitting on the bench, and the bench turned out really well, and I'm proud of this, and I'm glad it turned out great.
This has been my ENME435 final project. I hope you enjoyed. Thank you.